start off by pouring some of the stock solution into the cuvette. When you fill the cuvette, make sure it's filled up to that line.
Okay, so now I'm going to take this stock solution and pour it into the cuvette.
I'm going to take our second dilution and pour it into our cuvette.
And that's our third dilution.
Ensure you have a blank when you go into the spectrometer.
Behr-Lambert states that there is a linear relationship between concentration and absorbance. The variables in the equation are A, which stands for absorbance, epsilon, which equals molar absorption, L, which equals path length, C, which stands for concentration and molarity, and the equation goes A equals epsilon times L times C. We found a linear relationship between concentration and absorbance in our experiment, and we graphed it. The absorbance is measured in nanometers using a UV vis, and you will see examples of this in the next few videos. For reference, these are the absorption values we calculated in our experiment.
I'm about to place our blank cuvette into the spectrophotometer to zero the machine. And wipe it clean on two sides. Make sure I put these two sides into I'm gonna close it.
You will remember like you just because all you're looking at is to see your lambda max. Okay, gotcha. Thank you for lambda max. It's going to.
All right.
Okay, so this is our stock solution. I'm gonna clean it before I put it into the UV vis. Clean all the sides. Just keep the negative value. This. Did it pop negative again? Just close it and. Okay.
Okay, this is our graph, our absorption graph. This is the x-axis represents the wavelength, and the y-axis represents the absorption. So the wavelength that we need to record on looks like it should be 607.5.
We want to go 610?
No, wait.
No, because it goes up more.
We can do.
Alright, we're going to take our first dilution. I'm going to clean both sides.
After you found that, you can write that down.
And then I'm going to place it in the UV vis. We've already zeroed it out.
Stands right here. It's easy to remember because it's the only one that is big. Alright.
Alright, and now we're going to run it.
Yep. Perfect.
That's our
Alright,
first
so you're gonna go
abstraction.
setup. This is where
Absorption.
Dilution 2, and I'm going to start by wiping one side of it. Wipe a little bit dry. We already have it ready to read for dilution 2, so I'm going to put in the UV vis.
And then
And then we're gonna read.
ta-da!
This is our third dilution solution. We're going to clean one side or both sides. And open it. And then here. Raise it up. Then we're gonna read it. Our third absorption.
Now we have to write it down.
Now we're cleaning up our station to go back to the last dry calculation.
When using a UV vis, you need to scan across all wavelengths. The computer will then make a graph from these wavelengths so that you can see where the absorption is the highest. The point where the absorption value is the highest is called a lambda max. Finding the lambda max is useful in figuring out a certain solution's electronic properties, which is how you can determine what your unknown solution is.